So we are talking about time invariant and time variant system. So x of t system is there, we are getting y of t. Then see it from here. Okay, x of t system is there, y of t, then we did the delay of a t naught. So if you will do the delay of a t naught, you will get y of t minus t naught. And if you are initially doing the delay in input signal, and after passing from the system you are getting the same delay, means these two are same, then the system will be said as time invariant system. So for time invariant system, any delay provided in input must be reflected in output. Okay, so question is y of t is equals to x of sine t. So whatever the input you will put, x1 of t, so what the system is doing is replacing t with sine t as a output. So y of t, what we are getting, y of t we are getting as y of t we are getting as x of sine t. Now if I'll say you, if I'll delay this with particular some t naught, so what the things I will get as a output, x of sine t minus t naught. Okay, in this function the delay will happen. Now if I am saying I am delaying the initial, means input x1 of t, I am delaying this with t naught. So what the input I will get, x1 of t minus t naught, it will be passed from the system. Then what y of t I will get, x of sine t minus t naught. This function I will get then. So this is sine t minus t naught, this is sine t minus t naught. Okay, this is, from this it is minus of a t naught, and from this we are getting this inside the bracket. So these two are not same. So if it is not same, then it is time variant. Okay, delay means what? See, x of t, I am doing delay of a t naught, means x of t minus t naught. If x of sine t, delay of t naught, so x of sine t minus t naught. So this is the delay. Okay, so this is the meaning of delay. Now you guys have, I'm giving you one question, just say me what will be the answer of this. Y of t is equals to x of t square. So whether it will be time variant or time invariant, Prasanna, it will be time variant or time invariant. Priyanka,
Invariant, sir.
why invariant? See, you have a system, right? You are giving x1 of t. The system is doing what? It's making inside t as a t square. So you are getting x1 of t square as your output. Okay. Now if you will delay this signal, suppose you are having x1 of t square, right? You are delaying this signal. So this is my function. Okay, so I am delaying this by t naught. So what the things I will get, x1 of t square minus t naught I will get. Now if I am doing first delay, means x1 of t, then I am delaying t naught. So what the input I am getting? X1 of t minus t naught, and then I am passing from the system. If I am passing from the system, the system is making this function as a square, so this all will be a square. So x of t minus t naught, the whole square will come. So whether these two are same? No, these two are not same. So this is time variant. It won't be a time invariant. Now check it for this one. Third question. Y of t is equals to x of e power t. Whether it will be time variant or time invariant. Prasanna, whether it will be time variant. How you guys are saying that time invariant? See. So this is my system. So it's passing from x1 of t, my input. If I am giving input, so it's replacing t as a e power t. So I am getting x e power t. Okay. Now I am doing delay with t naught units. So what will come? E power t minus t naught. Assume this e power t as a t dash. Okay. Assume e power t as a t dash. So x of t dash. If I'll do the delay, then the result will be x of t dash minus t naught, and put the t dash value, e power t minus t naught. Okay. Now if I'll do the initial delay of a t naught as an input, so it will become x of t minus t naught. Then it's passed from the system. Okay, and what the system is doing, whatever the inside term is there, it is making as an exponent term. So x of e power t minus t naught is coming. Okay, so whether these two are same, here we have x of e power t minus t naught, and here in power we have t minus t naught. So these two are not same. So it will be time variant. It won't be a time invariant. So write the point, note point. If coefficient in the system relationships is function of time, then system will be time variant. See, so whatever the things, this is the system of in function of a time. Okay, so if a coefficient in the system relationships is a function of, so this is a coefficient, this particular is a coefficient of time. So this kind of a signal, whenever it will come, so you have to check like this. Now I am giving you particular one question. You have to say that whether it will be time variant or time invariant. So y of t is equals to x of t plus 10. Time variant or time invariant? So this is your system. You are giving x1 of t. So what x1 of t is doing? It's taking x1 of t and it's adding with 10. Okay. Now if I'll delay, this is my y of t. If I'll delay this with t naught, so I will get y of t minus t naught. Okay, y of t minus t naught. So what is the meaning? If you will delay this, so this function, you will get x1 of t minus t naught plus 10. Now if you will initially delay with t naught, then you will get x1 of t minus t naught. Now if you'll pass with the system this function, so this function, this is your input, so input is adding with 10, so x1 of t minus t naught plus 10 is coming, so these two are same, so that means it's time invariant. Time invariant. So this is your time invariant example. What about this? What about this? Y of t is equals to x of t plus sine t. So if you will do y, find y of t minus t naught, so what will come? X of t minus t naught plus sine t minus t naught. What is the function system is doing? System is nothing. System, if you are giving x1 of t, so it's taking x1 of t and adding with sine t. So whatever the input is there, so it's taking the as it is, and if it's taking in terms of a sine and it's adding. So if I'll delay first this x1 of t minus t naught, so what the things I will get? I will get x1 of t minus t naught plus sine t minus t naught. Yeah. No. Yeah. In this this is taking the input and this is adding with sine t. Sine t. This is taking the input and this is adding with sine t. So here also what will happen? It just simply add with sine t. So these two functions are not at all same. This function and these functions are not same. So it will be time variant.
Invariant, sir.
Invariant or time variant. See, understand this concept. You have y of t is equals to x of t plus sine t. What is my system? My system is this one. So system is what the system is doing? You have x1 of t. So this x1 of t will be like that only, and it will get multiplied added with sine t. Now you are doing delay here. Means putting x of t minus t naught. So if you'll put x of t minus t naught, if you'll do the output as a delay, what you will get? X1 of t minus t naught plus sine of t minus t naught. Correct? System will be. So this you understood. These two are not coming same. And now what I am doing? I am doing the delay. So I will get x1 of t minus t naught. Then I will pass from the system. So what the things you will get? X1 of t minus t naught plus sine t only you will get. Because the system property was to add sine t only. So sine t, it will add only sine t, not sine t minus t naught. So these two are not same. So if these two are not same, because here we are getting x1 of t minus t naught plus sine t minus t naught, and here I am getting x1 of t minus t naught plus sine t only. So if these two are not same, then that means time variant system will come. So write the note point. If any added or subtracted time dependent term is available in the system relationship other than x of t or y of t, then system will be time variant. For a time invariant system, three conditions should be satisfied. Write it down. For time invariant system, three condition should be satisfied. What is the three condition? First is there should not be any time scaling either in x of t or y of t. So there should not be any time scaling. So time scaling either in x of t or y of t. So if you are doing the time scaling, then definitely it's a time variant system. If there is a no time invariant, so this condition should always follow. Condition 2, coefficient in the system relationship should be constant. Coefficient in the system relationship should be constant. Any added or subtracted terms in the system relationship should be either 0 or constant. Write it down. Third condition, any added or subtracted terms other than x of t or y of t in the system relationship should be either 0 or constant. Okay, like example, write it down. Y of t, you have x of t plus 1 plus x of t minus 1. So this will be time variant or time invariant? What will be y of t minus t naught? X of t minus t naught plus 1 plus x of t minus t naught minus 1. Okay, now if you will put x1 of t as the input and you will do t naught delay, then you will get input as a x1 of t minus t naught. Okay, and the function was this. So it will passes from the system and you will get x1 of t minus t naught plus 1 plus x1 of t minus t naught minus 1. So these two are same only. So it is time invariant. Similarly, y of t is equals to conjugate antisymmetric x of t. Write the formula for conjugate antisymmetric x of t minus x conjugate of minus t divided by 2. So this will be time dependent, time invariant or time variant. So this is scaling is coming. So I told you if scaling will be there, then directly you can say time variant system. No need to do calculation. Automatically you are getting scaling. Reversal is there. So directly, even if you will check it y of t minus t naught. So what you will get, x of t minus t naught minus x conjugate minus t naught. Okay. So divided by 2. So these things coming. And when you will apply x of t, means first delay t naught, then it will be x of t minus t naught input. So what will the conjugate antisymmetric of this? X of t minus t naught minus x conjugate minus t naught divided by 2. So yeah, x of t minus t naught is there minus x conjugate okay. I did something wrong here. Okay, wait. This will be, if you are doing delay in this t minus t naught delay, so it will be minus t naught. Okay, minus t naught, and this is coming minus t plus t naught. See, yeah, you are doing delay in this, so x of t minus t naught minus x conjugate of whatever the things it's present, it will be as it is, minus t delay you are doing minus t naught, and now you are taking as an input t minus t naught. So x of t minus t naught minus of t minus t naught will come. So these two are not same because of the scaling. So whenever the scaling will be there, you can directly say the signal is time variant. Okay. Next question, y of t minus infinite to t x of tau into d tau. So this is no scaling, nothing, no scaling is there. So this we can say directly time invariant. Now fourth one, 11th one. See, if the same thing is given like this, y of t minus infinite to t x of tau into d tau. So scaling is coming, means two multiplications is coming in these two. So even if you multiply, suppose you are getting the integration as a x of t only, and when you put the limit, so this will become 2t. So scaling is coming, so that's why it's time variant. Now if you have a question like this, y of t is equals to minus infinite to t x of tau cos tau into d tau. So it will be time variant or time invariant. Time variant or time invariant. So this function is actually x of t into cos t. Okay. So this kind of a function is actually a time variant function. Okay. Time variant function. So if delay is come, y of t minus t naught delay if it's coming. So what the things you will get? You will get minus infinite t minus t naught, x of t minus t naught. Integration is also there, minus infinite t. So it will be cos t minus t naught. When you will make your input some delay x1 of t minus t naught, so what the output you will get? Minus infinite to t only, x of t minus t naught will be multiplied with cos t only to d t. So these two are not same, that's why it's time variant. Same manner you need to solve this one. 14, y of t it's given as x of t minus 1 for t is lesser than 0, x of t plus 1 for t is greater than equal to 0. What is the functions means? So it's, we can write is lesser than 0, lesser than 0. So lesser than 0 means x of t minus 1 into u of minus t. We can write like this in a equation form, and t is greater than equal to 0 means x of t plus 1 u of t. Okay, again see scaling is coming, this is giving me a scaling, so we can directly say time variant. Next question, y of t you are getting x of t power 2t. So what will be means by this kind of a question you can check directly. So y of t minus t naught, it will be x of t minus t naught power 2 into t minus t naught. Everything is replaced. Now you are giving the input x of t with delay t naught. So input is coming x of t minus t naught. So what will the output? What will the output? Output will be x of t minus t naught the power 2t only. So these two are not same. So it is time variant. Time variant. Now you have another question, last question. You have y of t is equals to cos x of t plus sin t. So these things we already know, because if you will give y as a t minus t naught, so output will be cos of yeah. See, this term is coming directly, you can say it's a time invariant. Or cos of x of t is there, x of t, x function is coming inside cos. So by seeing this also, you can say nothing we have to do, directly we can say this is time variant by saying this also. So if there is a means yeah, so this was the concept of time variant, time invariant. Now the last concept is invertible and non-invertible system. Okay. So what is the meaning of invertible and non-invertible? Prasanna, what is the meaning of invertible and non-invertible? Any idea?
Sir,
No idea.
one to one, one to one line only.
Yeah.
Many to
Correct,
one.
correct only. Invertible and non-invertible system. Invertible. So see, if there is one to one mapping between input and output, then the system will be invertible. If there is one to one mapping between input and output, then system will be invertible, right? So like minus 1 cube, what you will get? Minus 1. So this is invertible. And better example take, you have a system, you are giving minus 2 and you are getting minus 8. So what is the meaning? The system is doing cube. So minus, and from this, if we are making one system which will do 1 by cube, means 1 by cube, so we will receive our minus 2 value. So from minus 8 to minus 2 we can again reach. So this kind of a system is invertible system. But if you having a 2, suppose if you having a minus 2 and you are getting the system as a 4, then system is doing a square, and if you will do the square root, so you may get plus 2 or minus 2. So from 4 we cannot reach minus 2, we cannot say whether it will be plus 2 or minus 2. So this is non-invertible system. So what is the meaning of this? So for invertible system, it is possible to design inverse system. Okay. If there is a many to one mapping between input and output, then the system will be non-invertible. Write it down. If there is many to one mapping between input and output, then system will be non-invertible. So for non-inverting system, it is not possible to design inverse system. So what is the meaning? For non-invertible system, it is not possible, it is not possible to design inverse system. Okay, so when invertible system is cascaded with its inverse, the system gain of the composite system will be equal to 1. So what is the meaning? Write it down. When invertible system is cascaded with its inverse system, then gain of the composite means output by input, composite system will be equal to 1. So what is the meaning this? You have a one box, and this you have a invertible system, then you had design inverse system, so you are giving x of t input, you are getting y of t input, so again from the inverse system you will receive x of t. So output by input you are getting 1. Okay, now you need to check whether the system is invertible or not. First one is y of t is equals to x square of t. So it is invertible or non-invertible? Like we can check x of t, y of t. Put 2. So 2 square 4. Put minus 2. Minus 2 square 4. So different input, two different input, but the same output we are getting. So many to one mapping is coming. Many to one mapping. So 2 minus 2 is giving the same result. So many to one mapping. So this is non-invertible. Non-invertible. Okay. So we cannot design the inverse system like this. So what is the system is doing? Input a square. So x square of t. So even if we are multiplying input root, so this is not equal to inverse system. This is not equal to inverse system. So x of t or minus x of t we can get. So like if you are putting 2, you will get output as a 4. Then if you are making in under root, so plus 2 or minus 2 will come. So this is not exactly, means it is not exactly coming to. So if plus 2 is coming, then it's fine. But if minus 2 is coming, then it's not fine. So this is not an invertible system. Okay. Now if you have a system x of t and y of t, so it's given y of t is x of t to the power 1 by 3. So if I am giving minus 8, I will only get minus 2. If I will give 8, I will get 2. So whatever the input you will get different. Whatever the input you are getting different output. To one mapping is there. So the system is invertible. So it's very simple. What about this? Can anyone say me? Is this invertible or non-invertible? Y of t is equals to mod x of t. So whether it will be invertible or non-invertible? So if even if you will give -2 in input, you will get output as a 2. If you will get +2, 2, -3, 3, +3, 3. So -2, 2, both having single output only. -3, +3, both having single output only. So this is invertible or
Non-invertible.
non-invertible. So this is non-invertible. Okay. And what about this? If you have y of t is equals to x of t by 2, invertible or non-invertible? Invertible or non-invertible? If means suppose you are putting 8 as an input, output will be 4. 4 input, output will be 2. 2 input, 1. 16, 8. So all is getting a different output. So this is invertible.
Invertible.
Yeah, this is invertible. Same another example, y of t is equals to e power x of t. So x of t, this is my y of t. So if I am applying 0 to 1, I will get, if I'll apply x of t as a 2, so e power 2 I will get. If I'll apply x 3, x of t is 3, so e cube I will get. So this is 1 to 1 mapping. So invertible. So you need to say about this. Y of t is equals to sin t x of t. Invertible or non-invertible? Invertible or non-invertible? You know na, means if t value is pi, so y of pi will get 0. If t value is 2 pi, again we'll get, for 2 pi value, y of 2 pi value will get 0 only. So if t is pi, means you are getting 0. If t is 2 pi also, you are getting 0. So means your input is x of pi, your input is x of 2 pi. So because of this, we are getting a many to one mapping, means many input, single output we are getting. So this is non-invertible. Suppose now one question is there. Question 2. Y of t is equals to t plus 2 the whole square into x of t. Invertible or non-invertible? This is my x of t. This is my y of t. So I am taking x of t as a delta t. So if you will take x of t as a delta t, whatever the value present in the delta, so 1 plus, this is t, 1 plus t plus 1 the whole square. This is 1 plus t the whole square. So we know the impulse response, 1 plus t the whole square into delta t, whatever the output will come. So t minus 0 is there. Yeah. So we'll put the value of a t. The value of a t is 0. So we'll get delta t only. We'll get delta t only. But suppose you are putting your next input is 2 delta t plus 2. So what you are getting here? No. Uh, let's take 2 delta t you are taking. 2 delta t as a input. So what will be the output? 1 plus t the whole square into 2 delta t. So what you will get? So you will get 1 plus 0 because delta is t plus 0 only. So what the value of a t will come? 0 only. So put the value of a t is equals to 0 the whole square into 2 delta t. So you are getting 2 delta t. So like that you will see this is invertible. This is invertible. So you will understand these things only when you will revise the things because I told these things in a previous classes. X of t plus t, x of t plus something means like t naught anything. If delta t plus a is there, the result will be x of
T plus T naught plus E.
uh-huh. So these things you will understand from the revision only. So same concept is applying. I'm putting the value. Okay. See, in impulse response we had studied these things, basic signals, properties and all, everything we had seen. X of t, delta t minus t1. So, in place of t, you have to write t1. And the delta t minus t1 will be multiplied only. Go from this concept only using here. So here we having 1 plus t the whole square into delta t minus 0. T means what? T minus 0. So in place of t, you need to put 0. So you will get 1 into delta t. And here, in place of t, you need to put 0. But 2 is there. So 2, 1 plus 0 the whole square into delta t. So both are different. So this is invertible. So like in the same way you can check it. Your homework you can do. Y of t is equals to 1 plus e power t x of t invertible or non-invertible. Do by yourself. So this was the concept of invertible and non-invertible system. Now we will go for stable and unstable system. So how we are checking stability and instability? Any idea? Any idea? Priyanka, any idea? How we are checking stability and instability? Stable slash unstable. So what is the definition of a stable system and unstable system? Bounded input. If your input is bounded, your output must be bounded. Means if you are having a finite input, your output must be finite. Then only the system is stable. So this criteria is known as BIBO criteria. BIBO, bounded input, bounded output criteria. Okay. What is the meaning? Finite value. If you are giving the finite value to input, the output should also come finite. Finite amplitude means finite amplitude it's coming, then only the signal will be finite amplitude, then only the signal will be stable. So what do you mean by bounded signal? So some example of a bounded signal is like that: sampling of t, sinc function, sin t, cos t, dc value, u of t, signum of t, e power minus t u of t, etc. All are having, so sampling if you will see, so it's going like this, so it's reaching to 0. Everywhere the value is finite. Sinc also the same graph. Sine if you will see, so the value is fluctuating between +1 and -1. Cos also +1 and -1. DC value 1, a constant value. U of t 1 only. Signum of t +1 to -1. E power minus t u of t, it's reaching from e power minus t u of t. So at 0, 1. So 1 to infinite means 1 to 0 it's reaching. So everywhere values are finite. So this type of systems are called as bounded signal. If the output of the system is bounded or finite for a bounded or a finite input, then the system will be stable. Write it down. Write it down. If output of signal is finite for each and every instant of time, then signal will be bounded. So each and every, so what is the input? These t's are input. So if you will see at any instant of time, the output will be either between +or -1. Okay, in this graph here. So what the inputs we are providing? T. So any instant of a time we are getting the finite value. So this is bounded signal. Any instant of a t we are getting the bounded signal. So that's why it is known as a bounded input, bounded output signal. So if the amplitude of the signal is finite for each and every instant of a time, then the signal will be bounded. You can write like this also. If amplitude of signal is finite for each and every instant of time, each and every instant of time, then signal will be bounded. So what will be the criteria for unbounded? What 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 will be the criteria for unbounded? Guys, tell me. This is very easy. When the signal will be unbounded? When the signal will be unbounded? Just say. It's very easy. If the amplitude of the signal is infinite. If the amplitude of the signal is infinite, then the signal will be unbounded. So you need to check whether the signal is stable or unstable. So check signal is stable or unstable. So first question is y of t is equals to 4 plus x of t. So this is your input. So if you are applying input as a infinite, so what is the output you will get? Infinite. So this means unstable. Unstable. Okay. Now, if the question was like that, they had given you something like that 4x of t, and this x of t they had given like DC signal, or this x of t is given as a u of t. They had given like that. Then whatever the value you will put, you will get the finite value. So the system will be stable in that case. If the x of t is defined. Like the second question, y of t is equals to tx of t. So no, see, this won't be unstable. I'm really sorry. Because x of t you have to put the finite value only. Okay, your input should always be finite. Whatever the input, finite input you are putting. So if you are putting the finite input, you will get finite output. So for finite input, finite output in this kind of equations you will always get. So the system is stable. And if the equation is like this, tx of t, tx of t, so this will be, even if you will put the finite input, this might not be a stable system. How so? So suppose you are putting x of t, finite value DC signal value as a 2. So what the output you will get? 2t. If you'll draw the 2t curve, it will go like this. It will go like this. It's no boundary condition is there. So this is unstable. Unstable. What about this? Yeah. Third one is y of t is equals to x of t sine t. So this value you need to put finite only. And even means if your t is infinite minus infinite, so check it like this. So you are putting x of t as a DC signal. So something DC signal, some value is, some k value is coming, k by sine t, and whether it will be minus infinite, whatever the value, this value will fluctuate from plus 1 to minus 1. So overall we know that we'll get the finite value only. The system will be stable. Okay, this system will be stable or unstable. It will be unstable for one case. Which case? When you are getting 0 here. And when it will be 0? At t is equals to pi. So infinite value you are getting. Means any single time if you are able to prove that, oh, I will get the infinite value, then the system will become unstable. Like, so y of 0 you are giving, x of 0 is coming and sine 0 is 0. And suppose x of 0 is finite value, you are assuming. So finite by 0 is infinite. So you are getting output as a infinite. So bounded input but not bounded output. So input was finite but the output is not finite. So that's why the system will become unstable. What about this? Y of t is equals to cos x of t. So this will be stable. Why so? Whatever the input you are giving, whatever the input means, whatever the input if you are putting x of t, means whatever the finite input you are putting in x of t, the value of the cos of any functions, it will fluctuate from minus 1 to plus 1. So if even it will be 0 also, 0 is a finite value, so a stable function we will get, stability we will get. Right, stability we will get. What about this? Y of t is equals to minus infinite to t x of tau d tau. Stable or unstable? Stable or unstable? So see, if I am taking x of t, two different sets of input I am checking, and this is my y of t. So if I am taking x of t as a u of t, unit step function, I will get the value u of t. Okay. So integrations of minus infinite to t, and if I am taking u of t, so what I will get? R of t I will get. R of t I will get. R of t I will get. And if I am taking a x of t signal as a sine t, I will get some bounded signal, means cos function signal. So in this case, this is a finite value is coming. But when I am taking the input as a unit step, so unit step integration is R of t, and R of t is like this. So at infinite it's giving me an infinite value. So this is not a stable system, it's an unstable system. What about this? Y of t is equals to dx of t by dt. So check it. If you are taking x of t as a delta t, not delta t, taking u of x of t as a u of t. So differentiation of a u of t, you will get delta t. And delta is, we are having the infinite value at 0. This is infinite value. Area is defined, but the value magnitude is infinite. I told you in the previous class, impulse function. So it is unstable. So you have to check for that when it will become unstable. Okay. So there are lots of input. There are lots of input which will show it's stable, but you have to identify any single one which make this particular things unstable. Yeah. So suppose there is one question. Try by yourself. Y of t is equals to minus infinite to t x of tau cos 3 tau. So this will be stable or unstable? It is unstable, but try by yourself. Means putting the any value which make it unstable. If you will put x of t as a cos 3 tau, so it will give cos square 3 tau. So what is the formula of this will come? 1 minus 1 plus cos 6 tau divided by 2. Integrate this minus infinite to t. So this will give you t by 2 minus infinite to t, whatever the value you will get, you will give. So it will give you t by 2 plus infinite. So infinite is coming means overall will be infinite. So when the input is cos 3t, the output you will get infinite. So this single input, it will make the system as an infinite. Okay, I told you the concept, just try by yourself. So this was the story of stability and instability. Now we are moving to the next important part, that is LTI system, linear time invariants. Everything we had studied, linearity, time invariant. So this system is known as LTI system, and for making the transfer function we use this system only, LTI system only. Okay. So transfer function only calculate for LTI system. You can calculate the transfer function only for LTI system. Always remember. So we'll study this. Transfer functions of a system help in output calculations. When the output is calculated by means we will, by doing this LTI system we'll understand, we will know how to calculate the transfer functions and all. ZIR response, ZSR response. What I told you in networks, that this concept will repeat, ZIR, ZSR. So it will come now only. Okay, in LTI system. Okay, we'll continue tomorrow. I'm feeling a headache, so we'll continue tomorrow. LTI system. Okay, Prasanna. Okay, any doubt is there for you guys? Priyanka, any doubt? Just go through the concept, okay? Once revise the things. This is the basics things what I told you. Now the main chapter is coming. So within 10 days the signal till not 10 days, I will say 15 days the signal will be over. Then we will start control system. After that we'll start power electronics or whatever your choice. If you want to study machine, we can start machine, electrical machines, and then power electronics. Okay, but we need to complete a signal and system and control, then we'll go for the core subjects. Okay. Okay guys, thank you. We'll continue tomorrow.
Thank you, sir.